morning or good afternoon, depending on where you're calling from. My name is Kenneth Ubea with Digital Earth Africa, and it's today's live session. We are privileged to have Professor Hubert Hajemi from Afrigist in Nigeria, and today is presenting on some of the amazing work they're doing. And today's session is on downloading data from Digital Earth Africa Sandbox using a shapefile for an area of interest, which is very important for your work and analysis, and also recognizing the partners who've joined us from all over the continent. And over to you, Professor Sir.
Thank you. Can I share?
Yes, please. Yes, sir. Thank you.
Thank you. Okay. So you are welcome to the weekly lab session that we always have every Wednesday by 11 a.m. GMT. Our title today is downloading data from Digital Earth Africa Sandbox using a shapefile from a region of interest. Actually, it's one of the major issues that we always have when we get to a platform where we want to get our data from. We always want to get the area of interest, just cut our own area and go back. So I think we are no more going to have challenges anymore. We show each other how we can do it on the sandbox of Digital Earth Africa. So you are all welcome. Thank you very much. So we are moving. So we all know when we are talking about Digital Earth Africa, we know the vision of Digital Earth Africa that provides a routine, reliable, and operational service using Earth observation to deliver decision-ready products, enabling policymakers, scientists, the private sector, and civil society to address social, environmental, and economic change on the continent and develop an ecosystem for innovation across sectors. So Digital Earth Africa operates on various sectors. We have agriculture and food security, water resources and flood risk, land degradation, urbanization, and coastal erosion. And to those, all the ramifications related to all those sectors can be handled by the product of Digital Earth Africa. So when we want to view data from Earth Africa, you can go Digital Earth Africa map. You have the link that will take you to there, and you can be able to browse to any different type of data you want, either Sentinel or Landsat, or any other map data. Or we have our crop map data over there also. We also have our GeoMap data. So just go there and browse, you will be able to see all the possible data we are having. From that, on the Digital Earth Africa platform, you can go to Digital Earth Africa Sandbox, where we can be able to analyze data. All right, so we have the link that will take us to that platform. So, as I said, one of the challenges facing the Earth observation communities, that are the researchers, the students, and the project coordinator and others. Considering the challenges faced in some countries, for example, the bandwidth internet, the electricity constancy, the computer resources, etc., few questions could find the answer with this notebook. You have 3 questions, for example. Where do we get data from decision making? Can I get the raster data of a specific Digital Earth Africa product on my area of interest? Can we download them immediately for desktop application use? Yes. So the Digital Earth Africa Sandbox allows users to add external data such as shapefile to their algorithm. So this session will take us through the package that we are going to import. We are going to connect to the data cube. We define the area of interest, display the data set on a base map, create a query object, plot our results, rasterize the shapefile, mask the data sets, export a single tab/GeoTIFF, export a multiple banked single time slice GeoTIFF, export also multiple GeoTIFF, one for each time slice of an array. So this session will take us through all those elements. So hello.
Hello.
So yeah, it's okay. Thank you. The package to import, as we said, the first element is to import the package. This package are the package we need when you want to use the SNR data sets. So we have the package to import the system. We import the data in the data group. We import the NOMC, the pandas, the geopandas, the Digital Earth Africa tools, the Digital Earth Africa tool for plotting, the Digital Earth Africa utilities for importing and writing, Digital Earth Africa tool for spatial analysis, digital from IPA for the Python display import image, Digital Earth Africa tools plotting, and Digital Earth Africa tools area of interest import defined area. So to connect to our data cube, since every Wednesday we used to this, I think everybody has been getting conversant with the system. So we enter the following codes and run the cell. As we run the cell, we get connected to our data cube. After that, we define the area of interest. We create a folder for the purpose of the training directory. We download the zip file and extract on our local machine. We will upload the shapefile, either the shapefile. When talking about shapefile, when you want to upload the shapefile, make sure that all the 4 index we show. We have CPG, we have DBF, we have the shapefile, and we have the SHIS into the working folder. So we define the area of interest. We create a geopolygon and a geo data frame. We get the latitude and longitude range of the geopolygon. After then, we display the shapefile area on our base map. This is the code that I use to display the shapefile on our base map. So added to that, we create a query objects. We create a reusable query where we talk about the longitude range, the latitude range, the time from 2020 11/01 and 2020 12/15. The resolution is minus 2020. Measurements, we have the red, green, and blue. We have our EPSG and the minimum good data. We then identify the most common projection system in the input area and load data sets DS. Okay, when we load it, so we are working with Sentinel-2. Yeah. So we're using the pixel quality parameter for Sentinel-2, finding the data set that is a Sentinel-2, counting the good quality pixel for each time step, filtering from 1 to 6 out of the 11 time step with at least 80% good quality pixel. We are applying pixel quality clouds. We're loading the system step. We print the DS. When printing the DS, we are going to obtain those information that will tell us, according to the parameters we put, we have at least 6 images that have the properties of the parameters that we gave. Okay. After then, we plot the results. So we will display the return data sets using the RGB functions. This is the code using when using the RGB function. RGB DS index is equal to 1. This is our area of interest in the data frame. We rasterize the shapefile. Before we can apply the shapefile data as a mask, we need to convert the shapefile to a raster using the SR rasterize function. So, we have shapefile. The shapefile is not a raster. Okay. So before we apply the mask, we have to convert our shapefile to a raster using the SR rasterize functions. So this is the code that we are going to use for it. Mask is equal to SR rasterize geopolygons, GDF DS. For the number 8, we mask our data set now. We mask the data set using the DS where and mask to set pixel outside the polygon to not null. The DS, this is the code. DS is equal to ds.where mask. We plot the mask results of the data sets. So after then, this is our raster data that we are having following the pattern of our study area, the area of interest. This is the area of interest. So that is how we are going to get our area of interest. Later, we export the single band, single term slide GeoTIFF. This method uses the data cube utils.cog function writes. So these are the code that we are going to use to export the single bands. A few important should be noted when using this function. Okay. So we show you here, this is where we are going to do what we are going to do when selecting the single term slice and single band from the data set. So we write single band TIFF, and we write also the GeoTIFF to a location. And later we export it as a multiple band single term slice GeoTIFF. Here we select a single term and export all the bands in the data set using the data group functions. Okay. You can recognize this. The first one that we use is a red band TIFF concerning our frame, the function name. Okay. But when we come to this one, when we write the multi-band GeoTIFF to a location, we use the RGB TIFF, okay, as a name. So this, if you want to export all of our time spent in a data set as a GeoTIFF, we can wrap out the functions for a loop. So for I in range, we have our code. We use the date of the satellite image to name the GeoTIFF, the date. We convert the current time spent into array data array. And later we write the GeoTIFF. So when we write the GeoTIFF, we saw according to the parameter that we enter to our data cube, we notice that we have 6 images. So those are the images when we want to write the TIFF. That's 1, 2, 3, 4, 5, 6. So 2020 1109, 2020 1114, 2020 1129, 2020 1209, 2030 1209, and 2020 1214. Those are the 6 images that we could be able to get according to our parameters that we enter. In conclusion, you can apply this measure to already existing notebook and working with to continue with other analysis. So when you get this area of interest, is just a part of your work when you want to do some analysis. So this element you can introduce it to any other scripts that you are using that you could not be able to add your area of interest before. So you can add it now and get your area of interest before you continue the analysis. It is useful for selecting specific area of interest and for transferring information between the sandbox and GIS platform. Thank you very much. And also to download the notebook, this is where you can go to. So all the courses that Digital Earth Africa is taking is working. We have a Digital Earth Africa that's exercise in 2 languages. We have the English and French. We have some videos of us and of recorded video of the tutorials. We have some hands-on exercises. And after you finish those elements, you can be able to get a certificate of completion that can be awarded to you. And also, we at the beginning, I show you where you can connect with the Digital Earth Africa website. We have our Digital Earth Africa org. You have the free learning courses. You have the link, how to sign up for weekly session, and the email address if at all you want to have some questions. You have the information on Digital Earth Africa. You just send them the mail. And those are everybody that the collaborators that we talk. Let me give it to Ken so that I can be able to talk more about them. Thank you very much.
Thank you
Left to you, sir.
Thank you so much, Jamie, for the presentation today. So today you've been able to learn about these tools, and we'll be able to share the notebook as well with you. And also thank you so much for joining us in these Digital Earth Africa live sessions, including ways of you connecting with us, and as well as the link for the surveys included, so that we can improve the sessions as we also plan for next year. And also recognizing that today is among the GIS Day activities. I'm actually in one of those universities, Kenyatta University in Kenya. And hopefully, I know Afrigist is having a similar one in Nigeria, and colleagues are somewhere in Abuja, and everyone is doing something everywhere. So thanking you so much for joining us in these sessions. Next week, it will be in French by Professor Momadou Soma, and we keep you informed. Sessions are recorded and uploaded. Thank you. Thank you.